All right, guys, we are on our last section of this chapter. Two last formulas. So if you're looking at your green formula sheet, so hopefully you have that out in front of you. As you look through here, again, the problem comes not from can you use the formula, it comes from did you use the right formula. That's where all the issues come from. So simple interest, how do you know whether to use that one? It will literally say simple interest. If it doesn't say the words simple interest, you don't use it. Everybody got that? All right. How about APY? It will literally say what is the APY. Okay. Should you ever mess up on those two? No, you really shouldn't. All right. Now the other four, those ones are the ones that are a little trickier. Compound interest, again, we changed that one yesterday to future value of a single deposit investment, right? So technically we have two future value ones. One's a single deposit, one's periodic. What's it mean to be periodic? What? Say that again? I'm sorry, say it one more time. Every once in a while? Kind of. Consistent, not just willy-nilly, like throw in some money today, 6 weeks from now, a year from now. So not just every once in a while, but it's consistent. Every week, every month, every day, whatever. You're consistently putting in the same amount of money. Okay, so then today we have present value of both single deposits. So I'm putting in money once, and that's it. I'm just kind of letting interest do its thing. Or periodically. Now the difference though, future value wants to know how much money am I going to have in the future, right? It's the unknown, how much will I have. Today is like I'm saving money, right? Like I want to go on a vacation. I want to plan, I'm going to need $6,000 in 3 years when I go on my vacation. So how much should I put into it now so that I have $6,000 that many years from now? Okay, so it's like presently, how much should I put in now to get that in the future? Okay, so we're going to do both of those, whether I put in money once and I just want interest to accumulate it for me, or if I'm going to put it in ever so often and how much. So again, I try to break this down because this is where, again, we're going to have to learn to like really read in a problem to figure out which formula goes with what. So present value is the current value of a deposit that's made in the present time. So again, we have two future value, how much will I have in the future? Or to present value, how much should I put in now so that I do have that much? Okay, so it's all about what's the question. That's what you're looking at to tell which one's which. So what does it mean to calculate the present value of a single deposit? To calculate how much to deposit at a specific interest rate in order to have enough money in your account later. So for example, how much should I deposit into an account now so that I'll have $10,000 in 20 years? So in other words, again, if it's single, I want to put money in one time. One time, put it in, single deposit, and then let it go. Versus periodic deposit, how much should I save on a regular basis, on even intervals, right? How much should I put in every week? How much should I put in every month? So I have a certain amount. So how much should I deposit monthly in order to have $7,500 in 4 years? Okay, so I always think about vacations, right? You want to go on a nice vacation, you got to plan for that because it's going to cost money. So again, that's where to me, this is what I'm thinking about. Like, how much should I save every month? I would love to go on vacation right now, right? Okay, so again, here's your formula. Do you notice the variables or letters, the word that Joanne couldn't think of yesterday? What do you notice about all the variables? They're the same, but they're in different places, right? They look slightly different. Yes, good, you picked that up. Look where the balance is. It's in the equation. The other ones were B equals, right, because I wanted to know my balance. What was the balance going to be 10 years from now? So that's what you were solving for. Now I'm not solving for the balance. I know how much I want to have 7 years from now. I'm questioning the principal. How much should I put in order to find it? So again, if you're thinking through these formulas, think about the variables on here. Are you trying to solve for how much, the principal, how much should I put in? Are you solving for how much am I going to have, the ending balance? Okay, there's a difference there. Scientific calculator people, because I know this is going to cause some issues for you guys. So if you're typing these into a scientific calculator, you want to make the change on your green formula sheet because you'll get to use that. Thank you. Here you go, Kyle. All right, so again, scientific calculator people, that NT, you're going to have to calculate that ahead of time, just like you have been the whole time through. So calculate first. Right, you can't type in the 2 being multiplied, you have to type it in first. But you're going to also need an extra set of parentheses down at the bottom. So that's, again, only scientific calculator people. If you're graphing, you can type it in exactly the way you see it. Yeah, so you're fine. You can just type it in the normal way the formula looks. Scientific, you got to throw those extra parentheses on there. All right, let's take a look at it. Mr. and Mrs. Johnson know that in 6 years, their daughter Ann will attend state college. She will need about $20,000 for the first year's tuition. How much should the Johnsons deposit into an account that yields 5% interest compounded annually in order to have that amount? Round your answer to the nearest $1,000. Okay, because again, let's kind of think real quick before we get into this problem. Bless you. If you're planning to save for a vacation, right? And let's say you do all the math, you calculate all of this, and you come up with, I should put in $203.45 every month. Is it very likely that you're going to put in $203.45 every month? What's more likely that you'll put in? $205, right? Like, you would round things. Okay, so next week, we're going to look at your project for this chapter, which is going to be all about planning and saving for a vacation. You guys get to plan your dream vacation next week. Okay, so that's one of the things we'll have to do is we're going to figure out how much should I save in order to meet the budget of how much money we're going to have to figure out how much you need for this vacation. So I wouldn't save $203.45. If that's what it comes out as, I might save $205. I might put in $210, $225. You know what I mean? Like, you would round it to a nice whole number. Okay, so just keep that in mind for next week. All right, so again, part of the issue of this chapter is knowing which formula to use. So if you look at the question, how much should they deposit into an account? Right, so how much should they be putting in order to have that amount? So they're not looking for what's my ending balance. They're looking for how much I put in. What's my principal? So again, that should help you to realize which formula it is. It's the one that's P equals. I'm trying to find how much should I put in. I'm not solving for balance. Okay? All right, so principal equals how much money do we want? The ending balance needs to be 20 grand over, parenthesis, 1 plus my rate. I said it's 5%. It's 0.05. N, it's compounded annually. So what number do I use? 1. Parenthesis, 1 times how many years? 6. All right, so go ahead and grab your calculators. Again, practice with the calculators. What happens, it's terrible when you have the right formula written down, then you give me a wrong answer on the test. That's frustrating. Okay, so as you're looking at it, your calculator should give you $14,924.31. What do the directions in this problem say? Nearest $1,000. So what would I round that to? 15,000. So this is an example where they want to put money in one time, right? They're just going to take a lump of money. They're going to throw it in this account. So if they put in $15,000, in 6 years they'll have $20,000. So right, they'll make their money grow up to $20,000 by interest. So they have money for their daughter going to college. It's easy. You got to type the fraction in first. Just put the fraction in first. Okay, and then I literally typed in exactly the way this looks. All right, anybody else have questions, issues, calculator-wise? All right. So number 2, Jada just graduated from college. She wants $100,000 in her savings account after 10 years. Good for her, that's ambitious. All right, how much must she deposit in that account now at a 3.8% interest rate, compounded daily, in order to meet that goal? Round up to the nearest dollar. Okay, so how many times does she want to put money in? Just just once. She wants to stick money in it now. So that's going to be your single deposit. Okay, so we know, and again, how much must she deposit? So I'm solving for the principal. How much am I putting in? I'm not solving for the ending balance. Okay, so she wants $100,000. 1 plus her rate, 0.038. If it's compounded daily, what is that? 365. And then it'll be 365 times how many years? 10. Shouldn't be a weird answer. You should get $68,387.49. Oh, that's what you got? That's not what you got. All right, real quick though, if it says to round to the nearest dollar, what would that round up to? So would that round to 87 or 88? It'd be to 87. Yeah, so you would take this part off, round to the nearest dollar. All right, guys. And then the other one that we're talking about is the present value of a periodic deposit. So now this is, I am trying to periodically deposit money. So every week I'm going to put money in. Every month I'm going to put money in. Okay, versus here's one time I'm going to stick money in and let it grow. I'm going to continuously keep putting money in. And look at that formula. Isn't that pretty? It's all the same variables. They just, you get to use your green paper on the test. Yeah, otherwise you'd be flipping back and forth. Now, use your green paper on the test. All right, so scientific calculator people, extra parentheses for you. Right, you're going to need extra parentheses on the top to kind of hold the top together. Again, you're going to take the division sign for that fraction. The NT needs to be calculated. And then you're going to need extra parentheses on the bottom. Are they on the green sheet? Oh, they are on there. Well, all right, then never mind. It's already on there. Apparently, I was looking at two different things when I typed that up. There's a bird looking at you, Joanne. It's like right on the ledge. It's right on the ledge. See? Oh, it just peeked. Did you see it? It's funny. He was like playing peekaboo. Aw, you scared him away. He was learning from math. Come on now. Offended by that. All right, example 3. Nick wants to install central air conditioning in his home in 3 years. Oh, I don't know if I'd want to wait 3 years. All right, but he wants to install central air in 3 years. He estimates the total cost to be around $15,000. That seems really high. How much must he deposit monthly into an account that pays 4% interest, compounded monthly, in order to have enough money? Round up to the nearest $100. Okay, so again, I need you to recognize, how do you tell which formula to use? Obviously, we know which one it is because that's what we're working on. But I need you to see those little clues, right? How much must he deposit? So are you solving for the ending balance? No. So don't pick a formula that starts B equals, right? I want to know how much should I deposit now so that I have a certain amount in the future. And I'm depositing the money not once, but every month. So it's periodic. All right, so let's practice this lovely formula. So P equals, the balance I want is 15,000 times my rate, 0.04, divided by, if it's compounded monthly, what number is that? 12. All over 1 plus my rate again, 0.04, divided by 12. Then it'll be 12 times how many years? Minus 1. What? $300? No. $400. Yeah, because you should get $392.86. Uh-oh. So then that would round to $400. All right, are we okay here then? Good? Yes? All right. I said round to the nearest 100. So just round up to 400. All right, last one, example 4. Sunny needs to repay her school loan in 4 years. How much must she semi-annually deposit into an account that pays 3.9% interest compounded semi-annually to have $100,000 to repay the loan? Whew, she's repaying $100,000 in 4 years. That seems like a lot of money. Think about that. 100,000 divided by 4 is what? It's 25,000 a year. That's a lot. All right. Anyway, but we're talking about interest, so it won't be quite 25,000, right? All right. But again, in the future, which we're going to work on Monday and Tuesday, is looking at this, going, okay, which formula do I use, right? Because we don't know by just looking at it. So you have to kind of think about how much must she deposit, right? So how much must she deposit? So what would the principal be? Not what's my ending balance, right? I want the formula that's P equals. And I know it's this one, not the single, because of what? She's depositing it semi-annually. So it's not just a one-time thing and done. She's depositing semi-annually. Okay, so P equals, my balance, I need $100,000. Oh. All right. 0.039 over semi-annually, what's that? 2. So twice a year she's putting money in. We're doing this in only 4 years. Oh. Yeah. It's over what? Oh, you went to monthly. All right. Yeah. Oh. That's so weird. Awesome. No, more than that, because this is, we calculated how much she must deposit semi-annually. So it's every, how many months is that? It's every 6 months, because she's doing it twice a year. Wow. That's a lot. What do you guys think? So she better be having a better job than what some of you guys have chosen, right? I've seen your guys' annual salaries for your jobs you've picked. They range in this class for annual salaries based on those projects from like 30, I think there was like a $25,000 or $28,000 a year job, all the way up to you have a classmate who's going to make over $200,000 a year. It's Abby. She wants to be an orthopedic surgeon. She's going to make good money. You know what I mean? Like, so we're going from a restaurant owner or grooming dogs to orthopedic surgeon. You guys span a huge range of careers in here, which I think is amazing. I love to see that. But I hope that you're not saving for this and you groom dogs, because you're never going to live, right? You're not going to make ends meet if that's the case. I don't know. All right. Questions on these two formulas, whether it's single or periodic, and how to tell the difference? Good? Yeah?